Hello, everyone, and welcome to the open source tools, using open source tools to modernize the build of ZOS applications. This is an open mainframe project called Polycephaly. We're going to go over the materials. At the end, there'll be a live question and answer. So if you have any questions, please feel free to ask them at that time. I'll be on to answer those. Just a little bit about me real quick. My name is Jerry Edgington. I work for the Western and Southern Financial Group. I have been a ZOS systems programmer for almost 35 years. I've been doing Linux admin work, system admin work for almost 25 years. So I'm on the system side of the house, not the application side. So developing these kind of tools, I was trying to figure out how to get, those kind of taken to that account as far as what systems programmers times, and I'll get into that more. Also, I'll tell you where the name polycephaly came from, because I know it sounds like a disease. I haven't heard that a lot, but we'll go into that in a little bit. So first thing is Western Southern Financial Group disclaimer. This is basically just saying that Western Southern has nothing, they're not involved in this. This is my own viewpoint. So we'll continue on. So first of all, since this is a beginner one, what is Git and Jenkins? So Git and Jenkins are two open source products that are being used by a lot of companies in a lot of different areas to actually do source code management. And then Jenkins is the coordination or the open source automation server written in Java. So you have Git, which has all the tools and an implementation of Git. A Git server might be GitHub, GitLab, Bitbucket. There's a whole different range of things out there. Jenkins, there is open source, and both of these guys have support depending upon which way you go with it. But Jenkins it's basically an automation tool that helps develop or helps with the software development process. It can do builds. It's an orchestrator basically. There's several of them out there, but Jenkins and Git are the two that work with ZOS at this time. So here's the open mainframe project. Polycephaly is the one I'm going to talk about. That's my project. There are various other ones, and I think there was a new one just added too, which was just added within the last month or so. Polycephaly. The name comes from, if you see the little icon, it's something with multiple heads. So the reason the name came about for this project was I was trying to develop a way to marry the two different build methodologies from a Java environment, which I know a little bit about, and mainframe development, ZOS development. There are two different methodologies. Most of the time on the distributed side or Java development, the developer knows his pipeline. He knows where it's going to be done, where it's built, how it's going to be built. He needs to know all those components. He has to basically understand the scripting of how to do that. However, on the mainframe side and an SCM, they don't know that. A lot of those folks have the tools behind the scenes, are building the scripts, building the skeleton, building a JCL, submitting it for them. So they really have a lot of the COBOL, say for the COBOL compiler options, they're really sometimes all that's hidden behind the scenes to them. So how to marry those two together to apply what the Java developer does, but allow them to work in ZOS without having to know all those or having to worry about the scripting, and this vice versa, how to make the mainframe people have that same experience within the IDE, not having them to have to go into all the scripting parts, like for the Java, all the different class options. Now, if they develop in Java, they'll have to know that, but on COBOL, they don't. This project also allows you to be able to submit batch jobs to actually test the code. It's rudimentary, yes, that's why it's in its infancy still. But this project started almost over 4 years ago, almost 5. So long before some of these other projects and open mainframe projects started, I think. I'm not sure about that, but I've been working on this thing for a while that allows the mainframe to be using open source, not taking open source to the mainframe. So making the mainframe work on open source where it minimizes the impact on the developers, on the administrators, and including me, the ZOS systems programmers. Because quite frankly, you may have a developer out there. And in some cases, you have 15, 20, 25 to 1 developers, mainframe developers to one systems programmer. Well, the mainframe systems, the ZOS systems programmers, they're not many is out there anymore, and so adding something more complicated to this over an SMPE install makes it difficult. And I'll explain a little bit more about that later. But Polycephaly basically uses 3 roles. And I did this project to minimize the impact on everybody. So basically reusing what I can, where I can. And for example, the ZOS side install is all SMP installed. You probably have Jenkins and Git already installed in your system. So the Jenkins administrator can be able to develop or to be able to build and deploy the Polycephaly project, and everybody can use it. So it allows all 3 roles to be minimized what the impact on those 3 roles are. So where does Polycephaly sit within the DevOps enterprise? If you look at the highlighted piece in yellow, it sits in the build. So this is strictly just a build. At this point, it is strictly a build for ZOS applications, and I'll go over more about which ones, what products and stuff are in there. But it does COBOL assembler and a few others. So it will build these products from an IDE using Git and Jenkins on ZOS into PDSs, submit JCL, test the programs you just built or compiled, and go on and return the information back. So there's ways to do this stuff. It's just we're slowly gaining speed. Once we get the infrastructure built, we'll be able to move a little faster. So this is where we're talking about, is in the build component of the DevOps for the enterprise. So as you can see here, I highlighted a little different viewpoint. You see Jenkins and GitHub in the middle, along with Artifactory. So this is kind of like the pipeline, integrated pipeline. So where this fits in is up in the build section, not the coding, but the build. So this takes over where you get, say you get IDZ, Jenkins, and Git installed and running to the mainframe. This project will be a Jenkins project that'll be built and deployed to ZOS that other projects, other application projects can call. So it's hiding the scripting behind the scenes to mimic what happens with mainframe SCM. So the mainframe developer has the controls, yes, but it also hides a lot of the stuff behind the scenes so they don't have to worry about a lot of it. And then there are some ways to improve this, to the provisioning, to the deployment, the testing. But again, this is just in the build stage at this point. So that's where we come in, is everything we're doing right now for the Polycephaly project is in the build. And we'll show you a little bit more about that in a few minutes. So again, this is kind of a layout of how the things proceed. So from a developer has an IDE, and it doesn't matter what IDE they have. They build their code, they develop their code, they work on it, and they store it back to the Git server. The Git server can either be automated to say, go to, Jenkins notices the automate that the branch is out there and tells Jenkins to build it, or they can have, the Git server push it to Jenkins and say, hey, the notification. So it can be automated between the Git server and Jenkins, depending on what Git server you have. Jenkins will then start a slave. Now, one key to this is, if you have multiple ZOS operating systems and multiple sysplexes and multiple locations or whatever, the single Jenkins server can have slaves on every one of those ZOS servers. So if you've got, say, 3 around the country, this can actually build the same Jenkins service to those 3 ZOS operating systems. It goes into the USS. So the Git for ZOS is built. It's a Rocket port. It's SMPE installed. There's a few other things that need to be installed with this. There's an IBM tool, of course. You can't get away from ZOS without having an IBM tool somewhere. So it's not completely open source, but it's as close you can get, I think, without having, without actually using some of the other tools. So from the Git, so Jenkins starts a slave. He starts the process, the build on the ZOS under USS. Jenkins will then call back to the Git server via the GitHub or the Git client on ZOS that's been ported from Rocket, pulls the code down to USS, invokes the build part of the Jenkins invokes the build part, which happens to be, in this case, the Polycephaly project. It will then take the build, create development level PDSs as needed, depending upon what's being built. That's object, load, source, copybooks, macros or maclabs, whatever it needs to build with a high level qualifier specified in the build package. So all these parameters are in the repository with the build package. So whatever comes up, it pulls that. And when that's done building, you could actually have an auto submit a test case, a JCL, and then that JCL can run and we can have a notification back. That's still, that between the pass failure, that's still in works. But it could look at what the return codes were, send it back, and tell the developer back at the IDE it failed, or if it blew up or whatever. And they can, so the JCL, everything with that package, that program, the source, the Mac, the COBOL, copybook, everything is all in there. And there's some features within one of the IBM tools that I won't go into here, but it allows you to do, whether it's CICS or IMS, or DB2, it actually automatically puts in those features. So when it compiles, it knows that it has to invoke the built-in CICS compiler or translator, or DB2's translator. All that's already done for you. So that can go through and then do the build. It doesn't do anything with deploying the code except the load modules, and it only does it at the development level at this point. There are other tools for the deployment. I mean, there's tons of them out there that you can use for the deployment. I mean, you could actually take this code, the object code from the load library, since it's object code, store it in Artifactory as a build and binary format, and then deploy that to other ZOS operating systems. So it doesn't have, you can do one build on one side, say it's a test LPAR or whatever, and you can deploy that, store that back to Artifactory, then deploy that binary out to other ZOS operating systems also. So kind of like the copy method, you know, IB copy, when you copy it from one library to the other, you can do that with this. So if you have Artifactory, just like the Java does, they put the binaries out there, you can pull it through. So there's a lot of capability or possibilities. I mean, Jenkins has over, I think it was last time I saw was like 1,200 plugins to it, for everything from ServiceNow, GitHub, or Artifactory, Jira, all that. So this could also say that this test case JCL failed. It could open a Jira and have that be redriven back down to the developer saying, hey, you need to go look at this. So it can make a full loop. So this actually plugs in nicely to the DevOps deployment method, you know, CDCI. But again, Polycephaly is in its infancy at this point. So, okay, then you install and deploy Polycephaly to USS, and then all the other applications call Polycephaly, which then calls, or the applications called Polycephaly, which then does the build. Okay, so this is kind of the flow. I know it might be hard to read, but on the left is actually the administrative part, or the actual build, setting up the build. The green is where the actual build starts. And then on the blue ones with the lines are all the possibilities of what you can build at this time. So that's assembler, BMS maps, CICS APIs, web services, compile only, copybook, easy tree, JCL check. You can JCL check as long as it's not API authorized. It still needs some work. You can just link edit a program. We have a thing inside called dual compile. So we have one that goes for batch and one for CICS, the same modules. That was the routines were modified to allow that to do the build. So we push it to the two different spots. You can also easily switch back and forth. In this case, we have Expediter. I can easily set a program to say Expediter with one simple switch and put Expediter, it'll build the DDIO file, it'll build everything for it, then go to the compile. The ones in black are the finishing. So it does a build result, pushes it back to the DBB server, and then it puts the end time on it, and there's a build XML that gets kicked off. That'll actually do a little bit of deploys. That's an Ant script at this point. All right, so that's a lot of information, but that's pretty much the basic layout right now of Polycephaly. But the code that is in the blue is pretty much like a proc. If you have a proc that you do something with build, like we talked with another, the new project was just approved in the Open Mainframe project, we can actually build it as a module and plug it right into this. So if it's got a proc or it's got, you know, JCL, it can be put into Polycephaly code. So, all right, so let's take a step back. So what does this thing help with? So Polycephaly, with this flow that we have, allows the developer a lot of flexibility, which you don't have with mainframe SCMs. So for example, and I'll go more in detail, I'll show you some examples of this, but let's say I want to compile a complete COBOL application from start to finish. I'm upgrading from COBOL 4.2 to COBOL 6.2. So I want to be able to compile everything I can in COBOL 6.2 with a return code of 0, and anything that doesn't pass, put back in COBOL 4.2 and compile it there. And then if I have some test cases or test JCL, I can run those test cases against those programs and make sure it works. But trying to do that with a mainframe SCM is almost impossible. In here, it's a simple change. You have your COBOL 4s in one directory, you have COBOL 6 in another directory within the package, and then all you do is there's a selection routine that selects which programs you want to compile. You put as an asterisk in it, it'll compile everything. You can actually run multiple compiles. So you can say, just like the one before, I want to separate these into app 1 and app 2, where this one's a separate functionality within this application. So I just want to compile those programs. Now, there is the ability to compile just one program. So let me back up a step, because I think I might have lost a few of you with this. And I'll show you in a second. But with the Git repository, you get the entire library. So the way these things are, the way I've laid this out at this point is just like a mainframe SCM, there is one application per repository. So if I have like a mortgage application, all the mortgage application programs and JCL, copybooks, all those are brought down and in a Git repository. So when I go to an IDE and I want to start working on the mortgage application, I have to bring the whole repository down, which has all of those COBOL programs in. So I may only be working on one or two of those, or I may be working on all of them. So they're all in the repository. This is how you get your nonlinear development. You do that, and then you can promote it back in to the main GitHub or the main GitHub server, and then it'll do resolutions, or if you got a conflict or whatever. So it allows concurrent development. But every developer gets their own Git instance or Git repository when they do this. So when I say run a compile that runs all of the application or all of the programs, that means everything that's in that repository. Now, Polycephaly has the ability to select one program and run it. And there's ways to do that, and I'll show you that in a minute. But it also, you can compile your COBOL 4.2, 6, whatever, Expediter, Assembler, EasyTree, whatever. So you can actually hide a lot of in the Polycephaly project, but you can also allow the developer to override it. Another component of this too is it allows the COBOL program to have the compiler options with the program. So those compiler options, all these options and stuff that we're using, go with the program when you promote it. So one of the things with COBOL 6 that IBM recommends is that you run your testing or your development with SSRange, numcheck, parmcheck, and opt0, so that you can see what's going on. So those are testing compiler options that allow you to see what's going on with COBOL 6, whether there's a problem or not. And then they want you to recompile it after you're done testing with turning some of those features off, and then optimize it too to get full optimization. Well, that is kind of difficult with an SCM. With this one, and I'll show you here again, it's easy to make those changes back and forth, and only for a set number of programs if you wanted. So you can also move programs to different packages and compile them any way you want, with different options way you want. So there's a whole different, it's basically the freedom of doing what you need to do within the package. And as that package is promoted with whatever's been changed in that branch, it goes with it. So all the options, all the configuration, everything that goes with it. You can also have multiple developers developing the same application in the development environment to the same ZOS, because they can supply different high-level qualifiers. So by default, the high-level qualifier is set in the Polycephaly project, but it can be overridden by the developer. So you can also, if you have, like, say you're missing a Mac lib or a copy lib or copybook, now there's some features with IBM's DBB that I don't take advantage of at this point, so this is why we do this. But you can do the Mac lib and copybook, you can add right into the into the configuration. And again, that goes forward. So the next person doesn't have to figure out what happened. So the compiler options, configuration options, everything you compile that programs with are all right with the program at that release level or at that deployment level. You can change link edit options just like you would for any other COBOL program or whatever. You can change assembler options. You can have link edit control cards that are included with the link that goes with the program again and saved. And then by using the DBB interface to the APIs, you can actually see the dependencies and whether it's a CI/CD or not. You can see the dependencies back on the DBB. I'm not going to go into that at this point. The DBB is used, but you don't have to go through the reporting and stuff. It's minimally used just to keep the interface and some things alive. So that's where we're at with that piece of it. So here's this might be again hard to read, but here's the IDE, and as you can see the configuration files, you have in different libraries, you can have COBOL/app1 ***. That means compile all of those. So those are the programs that you can select. You can see that if you look at the options above in the green, you can have rent right in the middle. You can have the hello COBOL, you want as reentrant. You can have another program that has rent reuse, flag make 4 because it's COBOL 4. You can have, I want all the programs that are asterisk COBOL. I want them to be reentrant. I want all the programs in COBOL 6. I want the S-range. I want the hello 2 COBOL. I want that to be S-range, but then I can flip it back, as you can see in the middle of the screen. I can flip it back to be the no SS range. And then below that is a link edit. So I have my link edit for so I can have a default link edit ops for all my BMS maps, my assembler options for my BMS maps. I can invoke expediter. So there's your expediter ability. So any program that has the expediter tag on it will actually be compiled and built for expediter. You can do all the programs you want, or you can select which ones you want. And you can see kind of the configuration on the right. This is on the left side is the Project Explorer. Each type of program is in there. So you got copybooks, you have EasyTree, you got your JCO, you got your link edit. You can also, let's say I don't ever want to build this, or this program's coming out of the mix. I can still compile every program, but I don't want to compile this one. I can move that to another non-designated directory called no build, and then it will not build those. The naming convention within the Polycephaly determines whether it's going to get built or not built. So they're hard-coded, and you can see that within the Polycephaly project. And then you got down below that on the left is the build Groovy script. So this application executes a build Groovy script, which then calls the Polycephaly build Groovy script, which loads all the classes, and then that's what does the build. So the build Groovy script doesn't need to be changed. It's automatically set up to call the Polycephaly project, so you don't have to mess with it. So the routines that are in there, I talked about these already. There are a few of them that I haven't put in here: IAB copy, ICK DSF, ADR DSSU, IDChems, and then the DF CS YouTube is the one that builds the SOAP and the APIs. So there's a lot of things in here that we can add things real easy. Not a big deal to do that. And they can be, once we get the infrastructure built, we'll be able to have developers do their IDE, deploy it to the GitHub or the Git server, and then we can build it on the infrastructure and then actually test out the Polycephaly code itself. So give you an example of what I've done with what this tool has done. And you can tell this is back almost over a year and a half ago. On a 3 MSU LPAR, which is a very, very, very small LPAR with everything running, I ran 13 files. I ran 6 copybooks, 2 BMS maps, and 5 programs. It ran 34 seconds. 34 seconds from start to finish. Now, that's creating all the PDSs. That's putting everything up on the mainframe. That's putting the source book, the copybooks, creating the load library. All of that goes up there at one time. 34 seconds, and it used minimal amount of ZOS MIPS because all of the work, most of the work, probably 90% of the work is done on the Jenkins server, the Git server, and only when ZOS is needed does the work go to ZOS. So that's a big savings as far as the OS goes. Here's an application. I did a full build on one of the applications. Yes, it got an error. I wanted to show you this because I took the full application and set everything to go to Cobalt 6 compiler. So there was an error, yes, because some of the programs need to be changed to work for Cobalt 6. But again, on the 3MSU system, there was 330,000 lines, 71 copybooks, 145 COBOL programs, 22 easy tree programs. Took 49 minutes. So that's the communication time, building the PDSs, all of that. But that is a complete application, 145 programs, 22 easy tree programs. 49 minutes on a 3MSU, which is about, I don't know, 30 MIPS, something like that. So that is, majority of the work, again, was done off the mainframe. So Polycephaly is an open mainframe project. It is available, the code's available under the open mainframe project under Polycephaly. You can go download it. But remember, this comes into play